Hey guys, all right, this is at the beginning of the next section, and this is kind of a review of some of the stuff that you saw from Algebra 2. So we're going to go through it kind of quickly. I am going to remind you how to do this by hand, which I know is not something that you want to be reminded. And you are allowed to use your calculators for this, but before I review, and that's actually the very next link, is an online example of how to put it into your calculator and solve for this using reduced row echelon form. This is not a method that you actually used last year. You did use your calculators to solve, but this is a little bit of a different method. So I'd like for you to make sure that you watch the next video too in detail so that way you understand the two differences of how to input values into your calculators. But as far as going by hand goes, just a little bit of a review. First off, whenever you're naming a matrix, remember that it's row by column. So the row comes first and the column comes second. So on this, the rows are the ones that go horizontally. I have 2 rows, and then I have 2 columns, which are the things that actually stand like in front of a house. And speaking of in front of the house, someone just rang the doorbell. We're going to ignore that and hope that that was the bellman. Okay, so on this, we're going to have 2 rows in this direction, and then we have a total of 3 columns. So that's going to be a 2 by 3. Now, whenever it is a Mr. So for future reference, whenever the doorbell rings, you should always pause the video and immediately check to see who's at the door, because there's a very good possibility it could be someone like your boss. Now, because of the essence of time, I'm not starting this problem back over. I am simply going to continue on. But I would like for you guys to know that Mr. Skelton was just kind and did just swing by to drop off a little coupon for a little coffee to say thank you to his teachers. It's reasons like this that makes Faith Academy incredibly special, because never in a million years would that happen at another institution. So anyway, okay, I miss you guys. And we have something special at Faith. So I'm going to continue on now with this lesson. All right, so multiplying A, B. When you multiply these two things together, you have to pay attention to your dimensions. Okay, so 2 by 2 times a 2 by 3. The very first thing you want to do is make sure that your inside values actually match. Okay, so if they match one another, then this is a compatible problem. It will work. In order to determine the rest of it, you're actually going to take the values from the outside, this outside 2, and this outside 3, and that's going to tell you the dimensions of your answer. Okay, so you have 2 rows by 3 columns for your final answer. So the 2 by 2 on the inside tells you that it's compatible and you can multiply those two things together. On the outside areas, the 2 by 3, you're actually going to go 2 rows by 3 columns, okay? All right, so now when I do this, I'm going to have to do some mental math. I know that you guys really dislike mental math, but we want to go through and make sure that you understand how this works besides just putting it in a calculator, okay? So what we're going to do is we're going to begin when we're multiplying these matrices by taking the first row in the first column. So it follows the same scenario here, row by column. I'm actually going to take this first row by this first column. First row, first column is going to give me the term that is in the first row, first column. So I would multiply 3 times negative 2, which is negative 6, plus negative 1 times 3, which is negative 3. This gives me a value of negative 9. So my first row, first column is actually a negative 9. Then to move to the next term, it would be the first row, second column. Okay, so this would be 3 times 0, which is 0, plus negative 1 times 5, which is a negative 5. So 0 plus negative 5 is negative 5. Okay, and then for the last one, I would do first row, last column. Once again, mental math. So 3 times 6 is 18. Negative 1 and 1 is negative 1. So 18 minus 1 is 17. Okay, for the the bottom row, I'm going to go through, except I'm actually going to multiply bottom row by first column. So 4 times negative 2 is negative 8, plus 0 gives me a negative 8. Then 0 times 0, 5, that's going to give me 0 plus 0. That one's easy. And then this very last row by the very last column, 4 times 6 gives me 24 plus 0 leaves me with 24. And so my final answer here is going to be -9, -5, 17, -8, 0, and 24. Now, obviously, I do not expect you guys to do the mental math every time, but I don't want you to completely forget where this comes from. So it's good to kind of review this. Obviously, if you have a problem like this on an assessment, then you can multiply these two matrices together in your calculator, and that's okay. All right. Now, let's review this in the opposite direction. If I said B times A. Now, multiplication is commutative in everything except matrices. It's not necessarily true that it's going to give you the same answer both ways. So when I look at this, I have to pay attention once again to the size of each matrix. So we've already said that this is 2 rows by 3 columns. This is 2 rows by 2 columns, okay? And then your inside rows are actually not going to match here. So that means that this whole problem is not compatible. Okay, and that is going to be your final answer for this. There's nothing else that you would do, and that finishes the problem out. Thanks.